May, June 2016. It's a 2-hour paper. It's 100 marks. You've got question 1, which focuses on what? We spoke about this on Tuesday as well.
Yeah, today's not a good day, so I've had quite an intense day. Sorry,
Okay, well, what's the focus? Just give me the focus. I'll give you all the equations.
The equation of the line, so it's looking for the equation of the line.
Correct. Okay, so all straight lines follow what equation? Y equals mx plus
x plus
c. If I know that this line cuts the x-axis, what's the coordinates of those points?
Well, we've got 1 and 3, so if it's cutting the x-axis...
That's the other point.
Goes through the points 1 and 3, so it cuts it at 3.
Okay, this is referring to the x-axis, meaning that's the graph. This is the x-axis. So any line that cuts the x-axis at 3 will be there. Okay,
yes.
What's the coordinates of that point? It'll be 3 and 0.
0.
How many points do I need to draw a straight line? I need 2 points. Okay, that's why it's important to identify what they've mentioned in the question, because the only way we can find the equation of a straight line is by calculating m, which is y2 minus y1 over x2 minus x1. And then you've got c, which is the y-intercept. I don't have the y-intercept here. I'm going to have to work it out. Is it possible to work out the m, which is the gradient? Yes. I'm going to take this as my point 2. I'm going to take this as my point 1. So, if I have point 2 as being y2, which is 3, I'm going to subtract y1, which in this case was 0, because the other point we said was 3 and
0.
0. Okay, so 3 minus 0 over
1
minus,
is it also 1 minus 0?
3.
Oh, 3.
Okay, because it's the x2 minus the x1. If this is point 2 and that is point 1, then you'll have 1 minus 3. Right, so I need to work that out. Obviously, 3 minus 0 is 3. 1 minus 3 is minus 2. So the gradient is negative 3 over 2. I already know what the slope of that graph is in terms of the shape. Okay, so just to recap some theory, if m is positive, the line slopes that way. If m is negative, the line slopes that way. If m is 0, the line is flat.
Straight.
Okay, that's just theory.
Okay.
Right,
so
it's worthwhile knowing what the graphs look like, because when you have questions where they've given you graphs that you need to interpret, I need to know which way the lines are sloping in order to identify the different points. Okay, once I've got the m, now I can work out the c. Right, so y equals m, which I can now put in as, what was it? Minus 3 over 2.
3 over 2.
Okay, so that needs to be a minus, not a plus. Okay, so minus 3 over 2x plus c. Do I have the y-intercept? No, I don't. I can choose any point and I can plug those figures into the actual equation. So I can put in a 0 there, and then I'll put in a 3 over there, because those points lie on the same graph. Right, so if I put in 0 here, it'll be 0 equal to minus 3 over 2 times 3, close brackets, plus c. Now I need to solve for c, so minus 3 times 3 is minus 9. So I'll have negative 9 over 2 plus c. So c is going to be 9 over 2. Is that okay?
Okay. Yes, got it. So the answer is
that's
3.
The answer.
Yeah, so it's question 1 is 3.
Yes, okay, because you've worked out the m, you've worked out the c, you've done all the workings.
Okay, perfect.
Okay, so it's the same in terms of application. Just remember your formulas, substitute and solve, and then you get the right answer. Okay, question 2. Evaluate the following expression. When you see something like this, what must you do first?
Simplify.
Yes. Okay, try write this in a better format. Right, so if I write this in a better format, okay, we spoke about this on Tuesday again, just to revise again. Okay, root x, there's an invisible 2 there. So root x can be written as x to the half, because this is x to the power 1. Right, so another example. If I have x squared, okay, with a cube root, this would be written as x to the 2 over 3. Okay, that's just basics in terms of exponents. Those are some of the rules that the textbook would have discussed in terms of workings. Okay, obviously these are exponents. Exponents belong to powers. This is called the base. That's called the exponent, and the whole thing makes up the power. Okay, or the term. Right, so in this example here, I'm happy with a to the 5. I'm not happy with that. I need to change that to something I can work with. Well, I can work with that. And then I've got 2a to the 0, 3. Right, so what do I do when I see a's, same base?
So can they cancel out?
Then you add and subtract. Okay, so when I have x1 times x5, that gives me x6. I add the exponents.
Okay.
When I have, another example, when I have x7 divided by x3, what's the answer?
So it's 7 minus 3, isn't it?
Correct, x4. Okay, so that's adding and subtracting exponents. Okay, you need that in terms of this question, in terms of the simplification. Okay, simplifying the expression. Okay, so how am I going to simplify this? Well, very easily. I'm just going to take all the numbers. Okay, so I'm going to leave the 1 over 2 here. Okay, then I'll write down a, and then I'll write 5 plus 5 over 2 less 0, 3. If you do that on the calculator, you get option 3. 7.2. Okay, UNISA doesn't tend to put a comma here, so obviously there's missing commas here. Okay, but there's supposed to be a comma there, 7.2. Right, because 5 plus 5 over 2 minus 0, 3 gives you 7.2.
Wait, but I can't. Oh, okay. Is that an A? Okay, sorry, I can't make out on the exam paper. A 7.2.
Yeah, it's a to the power 7, 2 over 2.
2. Okay.
Okay, which is what we've got here, because we've got a half, so I can just write it like this: a 7 over 2.
Okay.
Okay, that's number 2. Okay, question 3. What's the focus here?
Determine the break-even points.
Exactly. So how do I get break-even points?
Oh, I can't remember. That's where total cost is equal to total revenue.
Exactly. Okay, so do I have total revenue?
No, you've got total cost.
Correct. So total revenue is?
Price times quantity, I think.
Exactly. So what is the price? 2. What is the quantity? Q. There's my total revenue. Do I have my total costs?
Yes, you got your total cost.
Correct. Okay, so break even is going to be no profit and no loss. So 0 total revenue minus total costs. Total revenue is 2Q. Total cost is negative 4 plus 6Q. There's total revenue. Total cost. Right, so what must I do? I need to simplify and solve. Okay, so I don't want a root, and I don't want it to be negative. So I'm going to take this to the left. So I'll have square root 4 plus 6Q equals 2Q. There's the formula that I've got. Okay, because there's no profit, there's no loss, it's break even. Okay, break even means total revenue minus total cost gives you 0.
Okay.
Okay, how do I get rid of a square root?
Well, can't you first split them?
No, you can't split it.
Oh, you take it to the other side?
We've taken it to the other side.
You've taken it to the other side.
Square it. If I square the left, I square the right. Okay, remember with an equation, you've got left-hand side equals right hand side. Okay, so the left hand side, if I square the left, I square the right, it's the same equation, just a bit bigger on both sides.
Okay.
Right, so if I square a square root, I get the 4 plus 6q. Okay, if I square this, 2 squared is 4, q squared is q squared.
Yeah.
Right, so now I need to take everything to one side, so 0 equals 4q squared minus 6q minus 4. Okay, can I simplify? Yes, I can. I can take out a 2 as a common factor. So if I take out a 2, I'll have 2q squared minus 3q minus 2.
Minus 2.
Right, can I factorize that? The answer is yes, I can. Okay, how do I factorize? Well, I'm trying to find numbers that will be multiplied together like this. That'll give me an answer. Okay, so 2 stays there. Okay, so factorizing works like this. You're looking at that number and you're looking at that number. Okay, you're trying to find numbers that will be multiplied together to give you a negative 3 in the middle when you add and subtract, and a minus 2 when you multiply. Okay, so I'm looking at the 2 here, which is 2q, so I'll leave that there. Okay, I'm writing small q's and big q's. I need to change it to all big q's.
No, it's fine. No, it's fine, don't worry.
Right, and then we've got 2q times what? Times q. 2q times q is going to give me 2q squared, which is this term over there, which is right. So I'm happy with that. Okay, then I'm looking at the end term. The end term is minus 2. So I've got an option. I can either put minus 2 here and 1 there. If I multiply those two together, I get minus 2. Or I can put the 1 here and I can put the minus 2 there. Because if I multiply that, I still get the minus 2. Right, so I need to check. If I use the first one, okay, 2q times 1 gives me 2q. Then I have minus 2 times q gives me 0. That doesn't work.
Okay, yeah.
Okay, so I have to use this. Plus 1 and minus 2. That's going to work.
Okay, okay.
Okay. Right, so if we wrap up the working there.
There's no other way to work that out.
There's no other way to work that out unless you have the quadratic equation.
Okay.
So the quadratic equation is, let me put it up rather, let me open up the file. Where's the formulae? Okay. Ooh, why is it taking so long? Okay, come on. There we go. Finally. Alright, so just to show the equation for the quadratic equation, it looks like this. There's it.
Oh, yes.
Okay, so if you don't know how to factorize, then you can just use that.
Okay, yes.
Okay, so minus b plus minus square root b squared minus 4ac over 2a, that's an option if you can't factorize. Okay.
Perfect. Yes, right, I know
so
that.
I'm going to use both then just to show you that as well. Okay, so if I couldn't factorize that, okay, well, let me just finish this bit first, and then we'll do that one. Okay, let's write 0 equals 2 brackets 2q plus 1 brackets q minus 2. So what can q be? Well, here, q can either be negative a half, or q can be 2. Can you have negative quantity?
No.
No, quantity is always greater than 0. Right, so this isn't an option. Mathematically, it's an option, but in reality, it's not. Quantity can only be bigger than 0. So only 2 would be the answer. So where's the question? Here's the question. How much are they going to need to break even? 2 units.
So the option is 3, yes.
Yes, okay, so if you couldn't do it that way in terms of factorizing, then you just do this. Okay, I wouldn't write x though, I would write q. Okay, quadratic equation. Right, so q equals minus b plus minus square root 4, forgot the b squared. b squared minus 4ac. Okay, if you're going to use the quadratic equation, you need to remember what it is. Okay, I don't use the quadratic equation because I can factorize. So for me, this isn't helpful because I don't really need it. Okay, but if you do need it, then you need to learn it. Okay, because they won't give you a formula sheet in the exam.
Okay.
Okay, so
but
that's worthwhile learning or studying. Okay, then we need to go back to our original question. Where's our original question? Here's it.
So that's 4q squared minus 6q minus 4.
You can use that.
Yeah, I know. Oh, and then
you can use the simple one, or you can use the more difficult one. Either or is going to work.
Okay, and then
let's use this one.
Okay.
That's fine. Okay, so 4q squared. What's the a? 4. What's the b?
Yes, it's
minus 6.
Mm-hmm.
What's the c? Minus 4. Do you agree?
4. Mm-hmm.
Okay, so let's put all of that in. I said my b was minus 6, so minus 6. Plus minus square root minus 6 squared minus 4. What is the a? I need to go back and check.
4.
Okay, the a was 4, the c was minus 4.
Minus 4.
Okay, minus 4. Close bracket, put a line there, 2 bracket, 4. Okay, then we need to simplify this. So minus and a minus is 6, plus minus square root. Okay, 6 squared is 36, so that's 36 there. Minus 4 times minus 4 is plus. 4 times 4 is 16. 16 times 4 is 64. 64 plus 36 is what is that? 90, 100.
Yeah.
Okay, over 2 times 4 is 8. Okay, what is square root 100? 10. 10 times 10 is 100. Okay, so 6 plus 10 is 16 over 8, or 6 minus 10 is what? Minus 4 over 8. Okay, so 16 over 8 is 2, or minus a half. Do we get the same answer?
Yes.
Yes, it takes a lot longer to get the answer if you're doing it that way. This you can plug into the calculator. Right, so over there, that step.
Yes.
That you can plug into the calculator and ask it to give you the answer. That's fine. And then just change the sign for a plus or a minus.
Okay, perfect.
Okay, but
yeah, because sometimes it's just difficult to factorize if you've got a number.
Yeah, so sometimes you can or can't factorize, then you need to use that. Okay, but you get the same answer ultimately. I can't have negative quantity. I can only have positive quantity, so that's my Q.
Okay.
Okay. Happy with that one?
Yep.
Okay, let's look at the next one. What's the focus in the next question?
Log.
Correct. Okay, when you see a question like this, you should be thinking about... I gave you a few page references on Tuesday for some theory from the textbook. I think this was on page 190 if I'm not mistaken. Where's my textbook? Oh, it's on that other desk. Just hold on a sec, I just need to get the textbook. So, page 190, let's just check that page. Was that the right page? Yeah, it was right. Okay, it's actually not 190, it's 191. Okay, but it was close enough. Okay, so page 191. Right, these are log rules. Okay, when you see two logs next to each other and they're separated with a negative, it means divide. So, I can take those two and I can write it like this. That's the log rule. That comes from page 191. Is that okay?
Yes.
Right, so can I cancel that? Yes. Cancel, 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 cancel. Left with 4. Okay, so log 2, 4. Right, remember on your calculator you've just got this log button. Okay, so if I don't have this button or this button, it looks different on different calculators, but it all does the same thing, where you can insert a 2 and a 4. Okay, if you don't have that, then how do I work out this on my calculator? Well, I just type log 4 over log 2, and that gives me the right answer. What do you get when you type that in?
2.
Yes. Okay, option 3. Okay, so log 4 over log 2 would be 2.
Perfect.
Okay, good. Right, focus in 5.
5. Sorry, I work with 2 screens, so I've got the one because it's bigger on my screen. Calculate the equilibrium price and quantity.
Great, so economics, right?
Yes.
Demand equals supply. What were you given here? You were given price for demand and price for supply. So are those two prices going to be the same?
Well, they're supposed to, because equilibrium is
You're right,
yes.
they're supposed to, because equilibrium is where those two lines cross. Okay, remember demand slopes down, supply slopes up. That point's equilibrium. That's what they want me to calculate. Okay, so when I have a question like this, I'm going to take the 20 to that side. I'm going to take this to that side. Doesn't matter which side you take it to, as long as you apply the correct mathematics. You could have done it differently, you'll still get the same answer. Okay, I'm just doing it that way because it looks easier. Okay, so 50 minus 20 is
30.
Right, if I take minus 0.6 to that side, it becomes plus. So I'm left with 1Q. Answer for Q is 30. All I need to do now is to get P. How do I get P?
You plug Q back into.
Good. Plug it back into that. Right, doesn't matter which one you plug it into. I'm just going to use that one. So minus 0.6 brackets 30. Close brackets. What does that give you? 32, I think. Yeah, 30 times 0.6 is 18. 18 minus, or 50 minus 18 is 32. 32 is the answer, option 1.
Yes.
Make sense?
Does. Perfect.
Okay.
That one's easy.
Right, what's 6 focusing on?
Number 6. Determine the arc price elasticity of demand when the price decreases.
That's important. Great. Okay, so now you've got that. Arc price elasticity of demand. Okay, I gave you a page reference as well for that. I'm going to refer back to the textbook because the textbook is the best resource when it comes to information. Price elasticity of demand, page 90 and 98. Okay, so let's check those 2 pages. Page 90. Is it there? Yes, it is. Okay, the arc price elasticity of demand. The equation is on page 90 of the textbook. Obviously, I want to use the simpler of the 2 questions. I don't want the more difficult one. So obviously, they've given you different variations of the formula. Okay, if you're looking at the arc price elasticity of demand, I'm going to write this one down. Okay, minus 1 over B. Then times P1 plus P2 Q1 plus Q2. Okay, obviously these are equations that you're going to have to learn going into the exam because you'll need them if they do ask for it. Okay, so here they did ask for it. I just need to substitute the numbers in and work it out. Okay, so a lot of calculations here from a substitution point of view. Okay, so let's substitute in the ones that I know. Okay, so what is the current price? 7, and it decreases to 5. Okay, so my current price is 7, and I'm going to then decrease it to 5. So P1, I'm going to just write, just to keep a tally up here, P1 is 7, P2 is 5. Okay, so where's my P1 and P2? There's it. So I'm going to rub those 2 things out, and I'm going to put in 7, and I'm going to put in 5. Okay, I need a quantity. Okay, so I need Q1, that's a question mark, and I need Q2, question mark. Right, so let's find the quantity. I need to put in the price. So I'm going to substitute that into there. So I'm going to write 7 equals 70 minus 0.5q. 0.5q is going to equal 63. Okay, then on my calculator, 63 divided by 0.5 gives me 126. Making sense?
That does, yes.
So I'm just substituting in to find the correct q's. Right, so that's the first one. The next one is going to be what? Well, 5 equals 70 minus 0.5q. 0.5q equals 65. Gives you 130. Okay, so now I can rub this out. And I can put in 126 and 130. Okay, now I need the b. Right, where does b come from? B comes from the formula for the actual equation for demand. Okay, so if you look at page 89, they give you the actual formula for demand, and they give it to you like this. P equals A minus BQ. So what is the B? The B is the number in front of the Q. So what's the number in front of my Q?
0.5.
You've got 0.6.
Oh, sorry.
Demand?
Oh, no, hold on. I scrolled down too much. That's why. Oh.
Do you agree?
No, you need to scroll down a bit. We're busy with question 6.
Oh, sorry. Wrong question. I was looking at 5. Yeah, 0.5 is
okay.
correct. Yeah, sorry, you're right. Sorry,
okay.
Wrong question. I was doing working up there. Yeah, that's the other question. No, not 5. We're looking at 6. Okay. So yeah, so the B is that. That's the B. Okay, so ED is negative 1 over 0.5 times, that's 12 over 256. Right, and if you type that into your calculator, you should get an amount. Let's double check it. 1 divided by 0.5 times 12 over 256. I get negative 0.09375. Okay, so answer here is none of the above.
Okay. So my only question is, for your B value, do you not have to take that negative into consideration or not?
No, remember the formula is given as that. Because remember, demand is sloping downwards, so it is going to be a negative.
Okay, so say the formula was, or P is equal to 70 plus 0.5Q.
Then you'd have to put a minus in.
Okay, so then it would be a minus. Okay.
Because remember, the arc price elasticity of demand is very specific to which function? The demand function. And the demand graph is sloping downwards. So the gradient must be negative.
Okay.
Okay, it must be negative. So the B is just the B. The negative is just representing the demand function sloping that way.
Oh, so okay, you're just looking.
If I put in a negative 5, let's see if we get an answer. What do we get? Yeah, then it just becomes a positive. Then it's going to be positive 0.09.
Okay.
Okay, it's still the same number, just a different sign.
Okay.
Still none of the above.
Okay.
Okay. Right, 7 is theory. You've probably covered economics, so you can probably choose the right answer already. You can probably give me the answer. What does elasticity mean or refer to?
As percentage change in quantity is not that. The between price and quantity demand and as above. I honestly can't even remember the changes in goods and price of a quantity's demand change in price.
Okay, because remember, price elasticity is looking at are you going to change your buying patterns if prices for goods change? If luxury goods change in terms of price, those are elastic goods because I'm not going to buy as much luxury goods if the prices change very drastically. But if the price of food had to change, I'm still going to buy food. It's inelastic.
Okay.
Okay, so it's the sensitivity of quantity demanded to a change in price. Are you going to change your quantity demanded based on price? Well, if luxury goods had to become more expensive, we'll still buy it, but we'll only buy a little bit.
But yeah.
Okay, if food goes more expensive, we still need to buy the same amount of food.
Okay.
Okay, so that's the theory. I don't know why they're testing economics theory in DSC. They did, but yeah. I think they should have been testing the maths, not the economics. I don't think that's fair from a test point of view, because they're testing quantitative modeling. They're not testing economics. But that's just my opinion. Okay, but make sure you do understand some of your economic theory, just so that if they do ask you theory questions like this, you don't come unstuck.
Okay.
Okay.
And you haven't started giving economics.
No, I don't cater for economics. I don't have a background in economics. If I did, then I would provide more. My background is more finance, accounting, investments, so those are the subjects that I focus on. That's my area of expertise.
Okay.
Okay, so unfortunately I don't offer economics at this stage. I am talking to other lecturers to see if they'd be willing to create videos for me to put on my website. We're still in discussion about that.
Okay.
Okay. Alright, so that's question 7. Question 8, focus here. You should like questions like this, hey?
Question 8. Question 8. Inequalities.
Yes. Okay, I think this is the one that I said to you on Tuesday, yeah. Okay, so you tell me where's the feasible region. Have they highlighted it?
No.
No, so...
I assume it's... Well, okay, no.
You can't assume anything because all the graphs are the same.
Yes.
Okay, so the problem with this question, it's probably... So when they printed the question papers, I'm sure the feasible region was very visible on the hard copies. But obviously they probably scanned this in. When they scanned it in, they probably didn't choose the grayscale, so it omitted the feasible region.
Okay.
Okay, that's my suspicion in terms of what happened here, because I doubt this was the original paper, because this is a PDF. It's probably scanned in, so the scanner didn't pick up the feasible region. Okay, but that's not going to stop us from doing the question. Okay, so how do I do a question? Well, I'm going to change the question in question 8 to this, to highlight the region. Okay, so we're going to highlight where the region should be. Okay, I don't know which option has the right feasible region, because all the graphs are the same. I'm just going to use graph number 1. Okay, and I'm going to highlight where the feasible region should be. Okay, so how do I do that? I have to look at the system of inequalities. Okay, so the easy ones. Let's start with 3 and 4. 3 says x must be bigger than 0. Okay, so if I look at the graph, where is x bigger than 0? Here, on that side. X is bigger than 0. Do you agree?
Yes.
Okay, where is y bigger than 0? It's above that line there. That's y bigger than 0. Okay, so you're not going to have anything in this quadrant or anything in that quadrant. Everything must be in the first quadrant. Does that make sense?
That does.
Okay, then I'm looking at the equations. Okay, I've got equation 1 and I've got equation 2. Right, so I know line 1 is this line over there. There's line 1, just to highlight it there. Okay, so what do I do to test which side the feasible region is on? I need to test values on the left and values on the right. So I'm going to test the origin because it's the easiest value to substitute in. Okay, so I'm looking at the left-hand side of this line. That's what I'm looking at. Okay, so let's put in a 0 here. If I put in a 0 here and a 0 there, what do I get? Well, I get 0 greater than or equal to 0 times anything is 0, 5. Is this statement true or false?
What do you mean if it's true or false?
Is
0
greater than 5?
Well, 0 can't be greater than 5.
Exactly. So this statement is false. Okay, so that means I cannot have 0 as a possible answer. So the answers must therefore lie on that side of the line. Okay, we can test it. Let me choose another number. I'm just going to choose a random number here. I'm going to use this one. Okay, I'm going to use 0.4 and 4. Okay, so let's plug it in. Right, if I plug in a 4 here, I'm going to get 4. Greater than or equal to 5 minus 2 comma 5 times 4. What's 2 comma 5 times 4? 10.
Okay.
Minus 10, right? What's 5 minus 10?
It's 5 minus 5.
Minus 5. Is 4 bigger than or equal to minus 5?
No, okay, so it's false.
No, that's true. 4 is bigger.
Oh, minus 5. Sorry, I was just looking at 5.
4 is bigger than minus 5.
Yes. Sorry, I was just looking at 5.
Okay, so if 4 is bigger than minus 5, which side can we have? We can have that side. Okay, so I can have numbers bigger than y bigger than 0, x bigger than 0, and any number on that side of the line.
Okay, perfect.
Okay, then I'll do the same thing with the next one. So put in 2. There's 2. Okay, so let's plug in 0. 0 is always the easiest. That's why I like putting it in, because it's quick, it's simple, it doesn't take much effort to add and subtract all of that. Okay, so if I substitute in 0, which is the origin, so I'm looking at this line, and I'm looking at the left-hand side of the line. Okay, so I'll put in a 0 here. If I put in a 0 here, I'll have 0 less than or equal to 3 minus x. 3 minus x is 3 minus 0. Is 0 less than or equal to 3?
Is not less or equal.
True or false?
True. No. Is
it is true.
Sorry. Okay.
0 is less than 3.
Okay.
So that is true. So that means I must have lines on this side of that line. Okay, so where's the feasible region? There's the feasible region.
Okay.
Alright, so if I knew which option had an option that looked like that, I'd be choosing it. Okay, that's
perfect.
the feasible region. Right, so I want one of these to be highlighted just on that bit.
Okay.
Then that'll be the option I'll choose.
Answer.
Whether it's 3, whether it's 4, whether it's 2, whether it's 1. I don't know which one is the option, but I know what the graph should look like. That's what the graph should look like.
Okay.
Okay.
I think we had that in our assignments as well. One of those.
It came up quite a bit in the assignment. It always comes up in past papers. Here's another one. Okay, this is a nice question as well. Easy or difficult? Easy, you just need to remember the equation for a parabola. Okay, f of x is ax squared plus bx plus c. C is the y-intercept. A is happy or sad. Okay, so what does this graph look like? Happy or sad?
So we've got a sad graph.
Exactly. So 1 is out. 3 is out. It's either option 2 or 4. Okay, so what else do I need? I need to know y-intercept. What's the y-intercept?
Isn't it 8? Is that an 8?
Minus 8.
Is that a minus 8?
Yes.
There's another little letter there. I don't know. I can't see on the...
It's a question mark next to it.
Oh, okay.
Okay, there should be a question
Minus
mark
8.
next to it. Yeah, they say which of the following graphs represent the function. They give you that, and then they give you a question mark.
Oh, okay.
Okay, so does this have minus 8? Yes, it does. Does this have minus 8? Yes, it does.
Oh, does it? Sorry, I can't see that well. Okay.
Okay, so now we're looking at the intercepts. Okay, I've got intercepts there of 1 and 4, and I've got intercepts here of 2 and 4. I need to check the intercepts. Okay, how do I find x-intercepts?
You the brackets, two brackets. What did
Make
you do
y
earlier?
equals 0.
Oh, and you can't factorize
Yes, you can. Okay, but to find the x-intercepts, y is 0.
Y is 0, okay, and then you factorize.
Because what is the y value for both of those points? 0. It's on this axis, right?
Okay.
Y is always 0 along that axis, right?
Okay.
Okay, so let's substitute. Well, not substitute. Well, yeah, we'll substitute the 0 in. So 0 equals minus 2x squared plus 10x minus 8. Okay, can I take out a common factor? Yes. Minus 2 brackets x squared minus 5x minus becomes a plus, 2. So plus 4. 2.
Oh, plus 4, sorry.
Can I factorize that? Yes, I can. If I can't, then I need to use the quadratic equation again, which I'm not going to because it takes too long. Okay, I'm just going to factorize. Okay, this is an easy one to factorize. You've got plus 4 there, so it needs to be a minus and a minus. You've got an x there, so it's an x and an x. There we go.
So x is 4, so x is 1.
X is 4 or x is 1. So which option is correct? There's 4, there's 1. I like that one. Here's 2 and 4. I don't like that one.
Okay, perfect.
Okay, you can also check the turning point. I'm just going to show you how to do that. Turning point we spoke about on Tuesday as well. The arithmetic is that. Okay, x equals minus b over 2a. Okay, so what is my minus b? It's plus 10, so it's minus 10 over 2a. A here is minus 2. So 2 times minus 2. What's minus 10 over minus 4? Plus 2.5. Okay, so there's your 2.5. There's the x value of your turning point.
Okay.
Okay, if you look at this one, they had a turning point of 3 and 1. That's wrong. But you didn't have to test that. Okay, I'm just showing you how to test the turning point in case you need it for other examples. That's the equation to work out a turning point. As long as you've got this, you can work out the turning point, the x value of the turning point.
Okay.
Focus here, number 10.
Find the equilibrium price and the quantity.
Exactly. Okay, so how do we do that?
Find the equilibrium price and quantity. So price is equal to quantity.
Yes, demand is equal to supply. Price equals price. Price demand is equal price supply. Make sense?
Yeah.
Okay, equals. Right, so do I want these denominators?
No.
No. So how do I get rid of a denominator? I times this side by q plus 2. I times this side by q plus 2. Okay, so if I times q plus 2, that cancels. That cancels. I'm left with 50. Equals. Okay, I need to times all of this out. 10 times q is 10q. 2q times q is 2q squared. 2q times 2 is 4q. And 10 times 2 is 20.
So 20.
Okay, so get everything to one side. So 0 equals 2q squared plus 14q. Then I'll have minus 50, so that becomes minus 30.
And you can take 2 out.
I can take a 2 out, yes. So that'll be 2 brackets q squared plus 7q
minus 15.
Minus 15. Right, can I factorize that?
Should be able to.
No, I can't. I can't factorize this. Okay, because 15 will be 5 and 3, 1 and 15. No, you can't. Okay, so with this question, you do need to use the quadratic equation.
Okay.
Okay, I want to show that working here. Alright, it's easy, it's quicker than having to write it down. Okay, so this is the quadratic equation for this one. Okay, so that's what I did on screen. Okay, we landed up with 2q squared plus 7q minus 15. That's what we had. Okay, I now use the quadratic equation. I'm substituting in b. Okay, let me write down what they are. B is 7. A is 1. C is minus 15. Okay, and that's what I plugged into the equation here. Okay, so x equals minus b plus minus square root b squared minus 4ac over 2a. Okay, so I square rooted all of that, and then I got those answers. So x came out as 1.72, or x came out as negative 3.5. Okay, I used Excel did the working for me. Okay, you can plug that into your normal scientific calculator and you'll get the same answers. Okay, so when looking at x and x, the one is negative 3.5 and the other one is 1.72. We don't have an option for 1.72 negative 3.5, so the answer is none of the above again.
Wow, okay, that's actually quite mean of them.
Oh, hold on. That was 10, not 11. Sorry, I circled 11's answer.
No, it is, yeah. Okay,
sorry,
but it's,
wrong one. The working here is for 10. That's the one. Yeah, so you see, you don't have an option there. None of the above again.
Okay.
Right, let's have a look at 11. What's the focus here?
Determine the roots of the function.
Roots, that's the key. Roots is another word for x-intercepts. I spoke about that earlier. Where do I find an x-intercept?
Where do I find an x-intercept? I can't remember, sorry.
I make y equals 0.
Oh.
Okay, so this would be my y because that's the function, that's the dependent variable. X is the independent variable. Right, so all I'm doing is just factorizing. Make the equation equal to 0 and factorize. Can I take out a common factor?
Yes. X.
Can I factorize that?
Yes.
Yes, I can. Okay, this is also an easy one. You've got minus 4 here. You want minus 3 in the middle, so minus 4 must be the bigger number. You'll have x and x, and then you'll have plus 1.
So x is 4.
So x is naught, x is 4, or x is minus 1. Option 1.
Okay, so we've had this before where we've taken a common number out,
yes,
but then we've ignored it.
Yeah, because that was a number, not a variable.
Okay, so the minute's a variable. Okay,
because this is x. X times this bracket times that bracket must give you 0. So x can also be a 0. 0 times anything is 0.
Okay.
Okay, so when you have a variable, you have to consider it.
Okay.
12.
The y-intercept and the coordinates of the turning point.
Exactly.
Rounded to 2 decimals.
Okay, that's important. Turning point, y-intercept. You already said it. Good. How do I find the y-intercept?
The y-intercept. It's C?
It is C, correct. Okay, so is this equation in the correct format?
No.
No. So what must I do?
Well, it's going to be minus 2x.
I need to fix it, hey?
Yes.
Okay, so let's fix this format. Okay, do I want minus 4 in front of y?
No.
No. So I need to get rid of minus 4. So I divide by minus 4. I divide everything by minus 4. Okay, so I'll have y equals. Minus over a minus is a plus. 2 over 4 is a half. X squared. Then I've got plus x over minus 4 becomes minus x over 4. Then I've got minus 1 over minus 4 is plus 1 over 4. Okay, so what's your y-intercept?
A quarter.
Exactly. A quarter would be either that option or this option. Okay, so 3 or 4 are possibilities. Okay, I want to know what the turning point is. How do I find the turning points? We spoke about it earlier for a quadratic equation. Minus b over 2a.
Yes.
Okay, what's your minus b here? What is the b?
Hold on. It's minus x over 4.
Yeah, so the number in front of x would have been the 1 over 4.
1.
1 over 4.
Okay.
This can be written like this.
Okay. Oh, okay. So it's 1 over 4. Okay.
Okay, so negative minus 1 over 4, close brackets, over 2a. What's my a?
It's a half.
What's 2 times a half?
It's 1.
1. Okay, so minus times a minus is a plus. X is a quarter as well. So x a quarter as well, there's it. Okay, so 3 is the right answer. Okay, you can already stop there. If you want to, you can check the y. It's worthwhile checking the y. How do I check the y then?
Would you just replace the x?
Yes, with what? A quarter. 0.25.
Yes.
Okay, so 0.25. So take 0.25, plug it into there, into that x, and plug it into there for that x.
Okay.
Okay, so it's a half brackets 0.25 squared minus 0.25 over 4 plus 1 over 4, and you should get the same answer.
Okay.
Okay. Happy with that one?
Yes, I'm happy.
Alright, 13, focus here. We spoke about quite a lot of these on Tuesday as well. They're popular questions.
Okay. So you need to determine the profit function.
Exactly. How do I get profits?
Total revenue minus total costs.
Correct. Did they give you total revenue?
No, they give you fixed cost and variable cost. That's your... No, they don't give you... It's fixed cost plus variable cost is total... No.
Total revenue
price
is what?
Price times quantity.
Okay, yes. Price times quantity. Did they give you price?
Fixed cost and variable cost. No.
Did they give you quantity?
Yes.
Okay, so 40p minus 0.2p squared is total revenue. Okay, I want total cost. How do I get that? Well, fixed plus variable.
Variable.
Fixed is 1,000. Variable cost is 15.
15.
Times Q. Do I know what Q is? Yes, I do.
Yes.
15 brackets 40 minus 0.2p. Okay, so 1,000. Okay, 15 times 40 is 600.
Check. Yes.
And 15 times 0.2 is
3.
3, yeah, minus 3p. Okay, there's your equation. Right, so I've got total costs and I've got total revenue. How do I get profits? This equation minus that one. Okay, so 40p minus 0.2p squared minus open brackets 1000 rather plus 6,000. This was
600.
600. Okay, so I can actually add those two. Let me add those two.
1,600. Yeah.
We'll save space. Don't have to put another line then. Okay. Minus 3p close brackets. Okay, so let's subtract this. Alright, so I'm going to be left with 0.2p squared. Okay, I'm going to have negative 1,600. Then I'm going to have 40p. Then a minus and a minus is a plus, so I'll have plus 43p. Okay, which option?
I need to see the answer again. 0.2p squared minus 16 plus 43p. It's option 2.
Yes, option 2.
Okay.
Question 14, focus.
The demand function. You have to determine the consumer surplus.
Do you remember how to do that?
No.
Okay, demand function, surplus, consumers, demand. There's the demand. The demand function does that. You're looking at the area under the graph.
Oh, okay, yes.
Okay, so what is my P there? 120. What P do they want me to look at? 80.
80.
I need to know what the quantity is. That's the price. Okay, so we first need to work out quantity. How do I work out quantity? Substitute P in. Okay, so 80 equals 120 minus 4Q gives you 4Q equals 120 minus 80 is 40. Q equals 10.
10.
Do you agree with that?
Yes.
There's 10. How do I find the area of a triangle?
No, I don't know.
Area is half base times height.
Oh, yes. Okay, yes.
Okay, so what's my base? 10.
It looks 40.
10.
Oh, 10.
What's my
Sorry,
height?
and your height is 40.
Good. What's a half 10 times 40?
A half times 10 times 40. 200.
Yes.
Oh, okay.
Okay. Make sense?
It does, yes.
Right. Okay, we've got quadratic equations here. Well, not quadratic, simultaneous actually. Okay, solve the following system of linear equations. I've got 3. What's the trick when you have 3?
Don't you have to get rid of one?
Correct. Get rid of one of the 3 variables. Right. Okay, so remove x. Okay, remove x. Okay, so if you multiply this by okay, yeah, this was the x. This was the x that I looked at, which was x equals 5 minus 2y plus z. Okay, and then that x went into that. Okay, that 2x. Okay, so then if I put that into that equation, equation 2 is 2 brackets 5 minus 2y plus z close brackets minus y plus z equals 2. Okay, so then 2 times 5 is 10 minus 4y plus 2z minus y plus z equals 2. Okay, so then you had, let's work that out now. This is minus 5y plus 3z. That goes across, it becomes minus, so minus 8. Okay, so that's what I had there. And then I had this, which was the y equals the 2 minus the z. Okay, and then I can plug this into that equation there. So then I had minus 5y, which is now 2 minus z, close brackets, plus 3z equals minus 8. Okay, then if I times that out, I get minus 10 plus 5z plus 3z equals minus 8. Okay, so then this is 8z becomes plus, then I get 2, so z equals
2 over 8.
2 over 8, which is 0.25. Okay, that was what? That was z. Yeah, z is 0.25. Okay, so now you've got z, which is 0.25. If I put 0.25 back into there, 0.25. 2 minus 0.25 is 1,75. Okay, so that's y, and then I need x. So now I can put in. Okay, so now I've got this. So then x here is equal to 5 minus 2. What was my y? 1,75. What is my z? We saw it earlier, 0.25. Okay, then I got x here. If you type that into the calculator,
5 minus
2 brackets 1.75, close brackets, plus 0.25, you get 1.75 as well. Okay, what did the question ask for? The question said the sum of the values x, y, and z. Okay, so what is the sum? Well, x is 1.75, y is 1.75, and z is 0.25. If you add up all of that, then you get option 4.
That's it, yes.
Yeah. Okay, so maybe a point to make here is that looks like sometimes you reach a dead end if you group it in one way compared to the other way. So I grouped it the first way, it didn't work. I grouped it the second way, it didn't work. So normally it should work either way, but that's when you have two equations. Okay, so when you have three equations, it's a bit more tricky because it looks like the grouping does actually affect the working. Okay, so the grouping does affect the working when you have three equations. When you had two, it didn't matter how you grouped it as long as you eliminated the variables.
And I think I also had trouble with the 3.
Yeah, the 3 is always going to be challenging. And I doubt they'll give you more than 3 variables. That'll be really, really bad. If they gave you 4, that'll be like crazy. Yeah, so I've never seen a 4 variable equation yet. I don't think they will give that to you though. Okay, but I have seen 3 and I have seen 2. Okay, yeah, but
well, they probably gave 3
to you previously is probably a bit better. Let me just show that to you. Yeah, I should have followed this working initially. I didn't know it wasn't going to work out if we grouped it differently. Normally it does. So if I grouped it differently, I didn't get the right answer. Here, I grouped those two to get rid of the x. Okay, then I used the arrow. I used those two equations to get that one, which is what we did. Okay, so what I did on screen gave us that 0.25.
Okay.
And then from the 0.25, you plug it back in, you get the right answers. Okay, so
perfect.
tough one here, 15. Okay, so yeah, challenging. Just be careful with the grouping. That's the biggest note that I need to mention there. The grouping does matter when you have 3 variables. Okay, just be careful.
Okay.
Right, 16. Find the values of x for which the function f of x has a min or max. We spoke about min and max. Where do we find mins and maxes?
When do we find the min or maxes? Where?
Derivative equals 0.
Okay.
Okay, so that's something you need to know when you have mins and maxes. Right, so give me the derivative of that. What's f dashed x?
3x squared minus 12.
Okay, make the derivative equal 0 and solve for x.
Oh, wait, why you got 4? Oh, no, it's 12. So 3x squared minus 12. Sorry.
X squared minus 4, hey? Yeah.
Mm-hmm.
Okay, so 3 brackets x minus 2, x plus 2.
2.
Okay, so what is x? 2
X
or
is
x
2
equals?
minus 2.
Minus 2.
Option 4.
Yes. Okay,
That's a nice one.
so I wanted to do that one as well now because, okay, so obviously this question was tough. That's an asterisk. Okay, I would have left that question till the end of the exam and then come back and do it. Okay, do all the easy questions first, then come back and do it. Okay, obviously I'm just going in order, but obviously you would have skipped that one and you would have done 16. Okay, so now we've got how many? 15 out of 30 questions correct.
Okay.